everyone, welcome back to Diksha Karnataka YouTube channel, and you are watching your favorite series Sankalp KCET 2026. And as promised, today I will start with a new chapter, Ray Optics and Optical Instrument. Today is the part 1 of the chapter, and we are going to discuss mainly about reflections and mirrors. So mostly this chapter, this part will be a recap of whatever you have learned in your class 10th. If you remember, you have learned similar things in your class 10th, so it is, you can consider this to be an upgrade over whatever you have learned in your class 10th chapter. But obviously, before we start, I will request you to join our WhatsApp channel. The link of the channel is given in the description. All the lecture notes, PDFs, all the updates that we are doing in our channel will be shared exclusively in our WhatsApp channel. So don't forget to join our WhatsApp channel. And obviously, if you are watching this video without being subscribed to our channel, so definitely you have to subscribe to our channel to get all the important updates for your KCET 2026 preparation, right? Let's before I continue with the lecture, let's look into our previous year result. So these are the toppers. As you can see, they have all studied from us through our exclusive YouTube channel only, and all the toppers names are also here. You can see every day. Why I show it to you? Just to tell you that if you continue to study through us and if you are sincere, definitely your picture and your name will be featured over here, right? And you will come to our office, will meet us, and we will have a very beautiful day with us, right? So but that is for all for future. For that you have to trust us, and obviously you have to follow all the lectures, not only physics, but you also have to consider physics, chemistry, maths, biology, all the lectures. If you follow it thoroughly, then nobody can stop you for achieving a very good result in your upcoming KCET 2026. And it is no longer a year away, so many people have still not started their preparation thinking, oh, this is still 1 year away. It is not 1 year away. As soon as that KCET 2025 exam was over, the clock started ticking, and you have merely like 10 months, 9 months in your hand. So use that time, prepare well. Also you have to prepare for boards and along with your KCET preparation. So we will take care of everything whatever you need. And here is the chapter 3. As you can see, today we are going to discuss reflection, laws of reflection, spherical mirrors, sign convention, mirror equation, and magnification. So these are our topic for today's lecture. What we will study in our next lecture is here: refraction, laws of refraction and Snell's law, refractive index, total internal reflection, and application of total internal reflection. This we will study in our next lecture. In our third lecture, we will study lens and prisms, refractions at spherical surface, refraction by a lens, lens equation, and refraction through a prism. So these concepts we will study in our third lecture. And for this particular chapter, we have a fourth part as well, where we will be exclusively discussing the optical instruments. Optical instruments, namely microscope and telescope, and their respective applications and some drawbacks if they have any. So that we will study in our fourth part as well, because questions do come from this optical instrument parts. Last year, if you are watching my last year's video, I have not covered this portion, but this year we will be covering this portion as well. Now let's continue with the first topic of the day, laws of reflection. Very common, you are studying it from 6th 7th grade. The angle of reflection equals to the angle of incidence, and the incident ray, the reflected ray, and the normal to the reflecting surface at the point of incidence lie in the same plane. Now maybe in the past, if you are just reciting them like a poem and writing in the exam would have worked, but from now on you have to understand what is the meaning of it, then only you can be able to succeed in life, right? Understanding is more important than reciting it as a formula or theory, right? So first of all, suppose we have a light. Mostly reflection not only happens for light, it can happen for any electromagnetic wave. Okay, for example, heat wave is also an electromagnetic wave, so reflection do occurs for heat wave as well. In fact, some mechanical waves, for example sound wave, also give you the same formula for reflection of sound. right? But it is more common for electromagnetic wave, it is common for mechanical wave also in some extent. Now if you see that so light ray, incident light ray means when you have a torch in your hand, if you light up that torch, whatever light is coming out of that torch, that is called incident ray, because it is falling on something. So when light falls on something, on a surface, okay, it basically gets reflected by the surface. Okay, and once this happens, what is the law of reflection? It says that angle of incidence is equal to angle of reflection. Now what is the angle of incidence? To measure angle of incidence, you have to draw a perpendicular on the plane, okay, on the plane where the light is falling. This is called normal. Normal is perpendicular basically. Generally for a single line, straight line, we say perpendicular. For a plane, more common general term is normal. Okay, normal is basically perpendicular to a plane. Plane is a two-dimensional object, right? So generally our straight line, whenever we say straight line, normal to a straight line also we say, but normal basically is a general term, whereas perpendicular is only specific for a straight line, right? So normal means when it is making an angle 90 degree. Okay, if you take a line along this angle would be 90 degree. That is the normal. That is the meaning of normal. Okay, so many students say, sir, I am abnormal. I want abnormal. I don't want normal. So this is not that abnormal normal. It is basically a perpendicular. Okay, some term, and the angle that it makes with the normal is called angle of incidence, and the angle it makes with the reflected ray is called angle of reflection. Okay, so angle of incidence, angle of reflection, they are basically equal. So theta I equals to theta R, very easy to understand. The second law, however, is slightly complicated, that this is a line, this is a second line, this is a third line, right? So these all lines are basically situated in a single plane. So just let me explain what is that meaning, because this two-dimensional and three-dimensional thing sometimes get confused. So first let us understand in terms of simple our one-dimensional form. So we have 1 point, okay, we have a second point. If we have 2 points, what we can do? We can draw a straight line passing through them. Okay, just ignore me. Even though I was trying to draw the single line, they did not pass through it, so sorry. So if you can draw a single line through 2 points, any 2 points, if you take any 2 points, you can always draw a line which basically joins the first point and the second point. No rocket science in there, right? Similarly, if you have two straight lines, okay, one line is like that, another line is like that, then you can draw a plane that passes through both the lines. Similar to that, okay, if you have 2 points, you can draw a line. If you have 2 lines, you can draw a plane. Nothing new in that, that is already known. But if there are more than 2 points, suppose there is a third point, can you draw a single straight line passing through all 3 of them? Single straight line. It may be possible, it may not be possible. If all 3 lines, 1, 2 and 3, if they lie on the same line, we say they are collinear. Right? If you remember, if 3 points lie on the same line, we call them collinear. So the problem occurs when the third point or third line comes into the picture. 2 lines, you can always construct any plane. No new thing about that. But as soon as the third point comes, it can be lie on the line, may not be lie on the line based on the location, right? But if they lie, we will say they are collinear. Similarly, in case of planes as well, 2 lines, you can always construct a single plane. Okay, but here it says that this normal, whenever you are drawing this normal will also lie on the same plane. the normal will also lie on the same plane. So basically they are coplanar. Incident ray, reflected ray and normal are basically coplanar. That is the main essence of this second law. Many students don't understand the second law, and in future maybe it is not super important right now, but some important question, some in-depth question that might come in your exam, and you don't understand the concept and you will lose on that, right? So it is very important to understand that incident ray, reflected ray and normal, they are coplanar. Let's see one question, very easy question based on simple reflection of light in a plane mirror. A ray of light is incident on a plane mirror at an angle of incidence of 30 degrees. The deviation of the ray produced by the mirror. So here we have a new term called deviation. Okay, what is the meaning of deviation? Suppose we have a light ray. It is passing in this direction, straight line. Right, light ray always passes in a straight line, that is ray optics. Okay, the fundamental of ray optics, it says that light always travels in a straight path. Now if you put a reflector over here, what happens is that instead of passing in this direction, the light ray changes its direction and moves in a different direction. So light ray changes its direction and moves in a different direction. Okay, let me change the color. Maybe this will be visible. Okay, yes. So the light ray changes its direction and moves into a completely different direction, right? So now this will obviously obey the law of incidence and law of reflection. So angle of incidence is given over here. So angle of incidence is 30 degrees. So this will also be 30 degrees. Now what is the angle of deviation? Angle of deviation means if there was no mirror present, the original direction of light, and once the mirror is placed, the reflected ray of light, whatever is the angle between them, that means this angle is called angle of deviation. It is very important to understand. Okay, it can be a mirror, it can be a medium, okay, transparent medium, it can be a prism, whatever it is, the final resultant ray, this is resultant or output ray, the output ray and the original input ray, the angle between them is called angle of deviation, and its symbol is delta. The symbol for angle of deviation is delta. Okay, and it can happen in any cases, does not specific to reflection. It can happen for refraction, it can happen for in some cases diffraction as well. So this angle is called angle of deviation, original path versus output path or the final path. Okay, so this is called angle of deviation, and they asked you what is the angle of deviation in this case. So this angle is theta, this angle is theta. Also we know that this angle is 90 degrees. Okay, and this total angle, because it's a straight line, this total angle should be 180 degree. Okay, this total angle will be 180 degrees. So from the geometry you can find for reflection the angle of deviation is given by 180 degrees minus 2i. Okay, you can check I plus I. In fact, in this case we do not need this 90 degree. Okay, this 90 degree is not required, only this angle is sufficient. So as you can see, this is I, this is I. Okay, so I plus I, 2i. This entire angle is 180 degrees. So 180 degree minus 2i will give you the angle of deviation, this angle. Okay, so 180 degrees minus, what is the angle of incidence? Angle of incidence given here is 30 degrees. So it will be 180 minus 60, that is 120 degrees. Now don't get confused with this angle. This is not the angle of incidence. Angle of incidence is always measured from the normal. So correct answer in this case is option 3. Now next we will move on to spherical mirrors. Okay, spherical mirrors, part of a sphere. So spherical mirror is a part of a sphere with one-sided silvered. Silvered, it can be silver, it can be used mercury also. So basically if you take a transparent glass sphere, part of a glass sphere, and if you paint any one side using silver or mercury, okay, basically you will get a mirror. Okay, now based on which side you are painting with silver, you can get either convex or concave mirror. There are mainly two types of spherical mirrors. Okay, so here you can see this type of mirrors are concave mirrors, convex mirrors, sorry. This is an example of convex mirror, and this is an example of concave mirror. Okay, now I always say that how to, as many students sometimes, if you have not paid attention in your class 10th, many students sometimes get confused between convex and concave mirrors. Particularly they that confusion is less in case of lenses, but in case of mirrors many students get confused. For that I always say that if you stand in front of the mirror, okay, and if you see that there is a cave like structure, okay, light ray will always come from left. Remember that light ray will always come from left. We will see that in the sign convention. But if you are standing in front of the mirror and the mirror appears to be caving in, then it is called concave. And if it is vexing out, if you are standing like this, and if it is vexing out, okay, then it is convex. Cave means that cave where you go in during your travel, you go inside something, right? There is one cave in near Visakhapatnam. If you have ever traveled there, Araku Valley cave, please let me know in the comment. So cave is basically when you stand in front of a mirror and the reflecting surface is going inside, you have to walk towards it, then it is a concave mirror, and if it is coming out, bulging out towards you, then it's a vex, that is convex mirror. Now sign convention, which is very very important to understand, okay, how we will measure the distances. Okay, we will use Cartesian convention, Cartesian sign convention. Here object is always kept on the left. Object is always kept on the left hand side, always, no matter what, starting position of the object will always be on the left hand side. Okay, and we will measure the distance along, this will be our origin, wherever the mirror or lens, okay, or the medium, wherever it is starting, it is intersecting this axis. Okay, this is called principal axis. Okay, the principal axis is the line which is joined from the bottom of the object towards the center of the mirror or lens, that is called principal axis. So this will be always our origin. What is the meaning of origin in geometry? Origin means its coordinate is 0, 0. Okay, origin means its coordinate is 0, 0, and this will be our positive x-axis, right? If you remember when we are drawing graphs, okay, this was our y-axis, this is negative y-axis, this is positive x-axis, this is negative x-axis, right? X, O, x dash, y, O, y dash. That's how we did the graphing, right? So here also we will use the same logic. Positive, anything positive of x is always in this direction, right? So if you measure any distance along this direction, that will always be positive, and if you are measuring any distances backward direction, that means the coordinate is negative, that means the value is negative. Similarly, if you are measuring anything upward is positive, anything downward is always negative y-axis, right? So if it is along the positive x-axis, it is positive. If it is along the negative x-axis, it is negative. If it is along the positive y-axis, it is positive. If it is along the negative y-axis, it is negative. Sign convention is very very important, especially when you are solving question and you have to put the sign. I have seen students, they understood the question, they have applied the formula correctly, but while using the sign convention, they have applied wrong sign or have not applied any sign. So that's why their answers are always wrong. So here, from here you have to understand that object distance, object is always on the left hand side. Object is always on the left hand side of the lens or mirror, whatever. And this is common for lens and mirror, by the way. This sign convention is common for mirrors as well as lenses. Both cases we will use the same sign convention. I am teaching it to you right now. We will not repeat this sign convention in case of lenses. Okay, only slight modification is there for convex and concave, that we will discuss. Other than that, normal sign conventions we will not discuss. Okay, so object will always be on the left hand side. That means object distance, which is denoted by u, is always negative. So whenever you see that an object is placed at a distance 20 centimeter from a lens, that means you have to add u is equal to minus 20. Okay, whenever you see a question, whenever you are seeing any question where object distance is mentioned, that distance you have to take negative when you are applying the lens equation. Okay, object distance will always be negative. Image distance can be negative or positive based on mirror, lens, etc. For example, here we are using a concave mirror, and the distance is more than the focal length, and you are getting an image which is real, so image distance is also negative. For mirrors, if image distance is negative, then it is a real image. Okay, if the image distance is positive, that means image is forming behind the mirror, then it is a virtual image. And exactly opposite for a lens system. For lens system, if image distance is positive, it's a real image. If the image distance is negative, then it's a virtual image. Okay, so you have to understand this. And one more way to understand is that where it is forming and what is system you are using. Okay, so are you able to place a screen at that position to observe that image, yes or no? If you can place an screen to observe the image, then that will definitely be a real image. If you are not able to place an image screen, you are just observing it through some mirror or lens, then definitely it's a virtual image. Right, now few more things. For example, it is a concave mirror, right? For concave mirror, focal length is on the left hand side, the curvature is on this side, right? So focal length is on the left hand side, so focal length is negative. Focal length can be negative and positive based on whatever system you are using. Now here, if you remember one thing, is that if you are seeing any concave, be it lens or be it a mirror, concave lens or mirror will always have focal length negative. Okay, concave surfaces, no matter lens or mirror, normally when it is placed in air, okay, which is very important, concave surfaces focal length is always negative, and for convex surface the focal length is always positive. Okay, for convex surface the focal length is always positive. Okay, this is a very basic understanding. You have to remember this sign convention, and this will last long, for a very long time, if you understand this very simple trick, because many students get confused with the what is the sign convention of convex lens, concave mirror, convex lens, convex mirror, so they always get confused. So if you remember this very basic foundation, that for concave focal length will be negative, no matter mirror or lens. For concave lens, concave mirror, focal length is negative. For convex mirror, convex lens, focal length is positive. Simple. Okay, clear? If you have any doubt in sign convention, please mention that in the comment below. I will try to explain that in our next video. Now, object distance always negative, as I mentioned. Image distance can be negative or positive. Focal length, concave mirror, concave lens is negative. Convex lens, convex mirror is positive. This is the very foundation of the sign convention. If you remember that, then your life will be much simple throughout your PU2 and in future if you study some signs. Now, And also you can teach that to your upcoming generation. When you become a teacher, some of you will become a teacher, and then you can teach that to your student who will come to you and asking, sir, please tell me how the sign convention is determined. I am very confused. Then you will remember, okay, Soumik Sir told me how to identify the distance. So my teaching through you will be passed on to your next generation, right? Now, image formation by a convex mirror. Okay, convex mirror is very easy to understand. Again, I am not doing the drawing and etc. Drawing etc. are not important for physics and theory. But if you really want, you can either open your NCERT book, or you can go back to your class 10th book and check it once. Okay, so there are few positions for which we will try to find the image distances. This is important, but exact diagrams, images are not important. So basically there are obviously for any lens and mirrors there are two important things: focal length and radius of curvature for mirrors, mainly mirrors. Radius of curvature we do not use for lens, but for mirrors we use. So here we have a convex mirror. So you can see that this is the mirror. This cross sign represents whichever side is not crossed, that is the reflecting side. This is the reflecting side. Okay, now when the light is falling, so here we have a focal length, here we have a radius of curvature. Okay, there is a relationship between F and R as well. We will do the derivation of F and R in our exclusive PU series. For now, you should remember that radius of curvature is basically twice of focal length. Radius of curvature is twice of focal length, right? Now when you place any object, in this case as you can see, the object wherever you place, okay, it will always be on the left hand side. So for left hand side objects there is only two position possible: finite position and one infinite position. Okay, so either the object will be very far, so that we say the object is at infinite position, or it is closer to the mirror and we will say this is the finite position. You can measure it using a scale. So at infinity, when the object is at infinity, so you will start with the infinite position. Okay, the image will form exactly at focus. Image will form exactly at focus behind the mirror, not the lens, behind the mirror. Okay, highly diminished and point size. It is the very small and diminished, and it will be virtual and direct. It will be virtual and direct. Between infinity and the pole P, pole is this one is pole. Okay, between infinity and pole P of the mirror, again sorry, this will be mirror. Okay, between P and F, behind the mirror, so between P and F, so image will be forming over here. If you put it in the finite range, then the image will be forming over here and it will be diminished. Diminished means size will be smaller, and it will be virtual and erect. Virtual and erect means upright. Okay, it will be the same direction as the object, right? Now image formation by concave mirror. So first, if the object is at infinity, the focus, it will be formed at focus. Okay, highly diminished, point sized, real and inverted. Okay, even though it is very difficult to identify whether it will be real or inverted, but there are some techniques through which you can determine it, because the object will be very small size, but you can, there are processes through which you can even determine the nature of this object. Beyond 2f, if the object is beyond 2f but between not at infinity, okay, then it will be I will rather say not 2f, I will say beyond r. Okay, radius of curvature r, it will be between f and r, and it will be very diminished, and it will be real and inverted. Okay, it at r, at radius of curvature, radius of center of curvature r. Okay, it will be exactly at r. Okay, same size, real and inverted. In fact, image and object will be at the same position. So image and object and image will be at the same position, right? Between r and f, between R and F, it will be beyond R, okay, it will be enlarged and real and inverted again, okay. At F, the image will be at infinity, highly enlarged, real and inverted. Between P and F, behind the mirror, okay, enlarged, virtual and direct, okay. Now let's continue. Short summary, let's look into a short summary. Convex mirror forms only virtual and diminished image. Convex mirror can form only virtual and diminished image. It cannot form real image for real objects. Okay, obviously objects should be real. There are some cases where you might see that convex mirror is forming real image, very special case, but that is where the object itself is virtual, not real. So that's why it might happen. But for real object, if nothing is mentioned, then object is always real. If nothing is mentioned, object is always real. Okay, forms only virtual and diminished image. Okay, and for concave mirror, it can form real and virtual images both. Okay, if it is given to you that a mirror which can form only virtual images, that means they are talking about convex mirror. If they are saying that the formed image is virtual, if they say the image formed is virtual, then you are not sure whether it is concave lens or a concave mirror or a convex mirror. Both is possible. Okay, for object distance greater than F, it forms real images. Okay, if the object distance greater than F, so if it is the mirror, if this is the focal length, any object placed beyond F, okay, the image will always be real. Any object placed between F and P, for object distances less than F, it forms virtual and enlarged image. So you have to understand that if the object is enlarged, if the image is enlarged and virtual, if the image is enlarged and virtual, then it must be a concave mirror. If the image is enlarged and virtual, convex mirror forms virtual images, but that is always diminished. Okay, always diminished. If the image is enlarged, then only one mirror can form enlarged image, that is concave mirror. Okay, for lens it will be opposite, but you have to understand that for any enlarged object, image, the mirror will be concave mirror only. Convex mirror cannot form any enlarged image. For a point object, which of the following always produces virtual image in air? Okay, plano convex lens, convex mirror, biconvex lens, concave mirror. So you always know that convex mirror will always form a virtual image when it is placed in air. Now let's continue with our discussion. This is the mirror equation. This equation is called mirror equation. 1 by V plus 1 by U equals to 1 by F or 2 by R. So as I said, the relationship between F and R, so R is basically 2F. Okay, so this is the reflection of all the formulas. Now here you have to remember the sign convention is applicable in this formula. Okay, this formula is valid in all situations for all spherical mirrors, for all positions of object. There is no restriction in this formula. Okay, but you have to understand that you must have to apply the new Cartesian sign convention while substituting the numerical values for U, V and F. So the new Cartesian sign convention, that we have learned that any object, anything on the left hand side is negative, anything on the right hand side is positive, basically x and y axis. Okay, so that sign convention you have to apply when you are putting the values of U, V and F. Okay. Now let's see one question. This is a question from KCET. The year is not mentioned, but I am very sure, I think 2020 or 2021 this question came. A point object is moving uniformly towards the pole of a concave mirror of focal length 25 cm along its axis as shown below. the speed of the object is 1 meter per second at t equals to 0. The distance of the object from the mirror is 50 centimeter. The average velocity of the image formed by the mirror between the time t equals to 0 and t equals to 0.5 second is. So here we have a mirror, concave mirror. The initial distance is given, focal length is given 25 centimeter, and its speed is given by 1 meter per second. Speed is given by 1 meter per second. The distance of the object from the mirror is 50 centimeter. Initially it was at 2f. Initially it was at 2f. Okay. So basically if initially the object was at 2f, then the image will also form at 2f. Okay. Now after 0.25 second we have to find the final position of the object. Final position of the object we have to find, and correspondingly we have to find the final position of the image as well. So from there we can calculate the average speed. Okay. So let's see how to find the final position. So it is moving, the object is moving towards the mirror with a speed of 1 meter per second. Okay, object is moving towards the mirror with a speed of 1 meter per second, and what is the time given here? Time given here is 0.25 second. Time given here is 0.25 seconds. So what is the displacement? Displacement is s equals to v into t, that is 1 meter per second into 0.25, that is 0.25 meter, or it will be 25 centimeter. So 25 centimeter is the displacement from this side. So what is the final distance of the object? Final distance of the object, say UF, is basically 50 minus 25, that is 25 centimeters. So the object is now located at a distance of 25 centimeter. Now if you read the question carefully, it is same as the focal length. That means the object is now, initially it was at the center of curvature. Now the object is located exactly at the focal length. The object is located exactly at the focal length. You don't need to do any mathematics. We know that when the object is located at focal length, the image is formed at infinity. The image is formed at infinity. So if the image is forming at infinity, what is the final image distance? Final image distance VF is basically given by, here this V is image distance V, here this V is velocity V. Okay, so this will be nothing but infinity. So image will be formed at infinity. Why? Because this is exactly as the focal length. Okay, from the theory we have learned that if the object is located at focal length, image formed at infinity. So what is the displacement? Displacement of the image, displacement of the image final distance minus initial distance, which is exactly equals to infinity. So what is the average speed? Average speed VAVG is displacement divided by time interval. Displacement is infinity, time interval is 0.25, that is infinity. So the speed of the image will be infinite. Right? I could have simplified and solved the answer question here also, but I just wanted to show you how this is done. In case you see another question where this point does not come out to be f, then you have to find the final position, and then displacement will be calculated by final position minus initial position, and from there you can calculate the speed. This case is easy, so you get the infinite answer as infinity. Let's see next question, magnification. So what is magnification? Magnification in case of mirror is given by m equals to minus v by u. You have to remember magnification is different for mirror and lens. The equations are also slightly different, but don't forget, for mirror is minus. Mirror is minus. If you remember that, then your problem will be solved. Mirror is minus. M for minus. Okay, so M for minus for mirror. M is generally gives you the magnification. What is the meaning of magnification? Suppose your object is this big, and your image is this big, then you will say it's a positive magnification. Positive magnification and object is basically higher, so it is m greater than 1. M greater than 1, obviously. If the image is larger, but again it is in the opposite direction, then m is negative. M is negative, but magnitude of m again greater than 1. Magnitude of m is again greater than 1. If the image is smaller, compared to your object, if the image is smaller, then the value of m will be less than 1, but it will be greater than 0. Okay, it will be greater than 0 but less than 1. If the object size is smaller, this is diminished. In case of diminished object, greater than 0 but less than 1. Okay, and if it is negative, obviously then it will be inverted, but same thing will happen. Magnitude wise it will be the m 0 greater than 1. Okay, so you have to remember that magnitude for magnified objects will always be greater than 1. It is called magnified and this is called diminished. Diminished means image is smaller. If the image, this is object, this is image 1, this is image 2, this is image 3. Okay, for diminished inverted, generally we do not see inverted diminished. In case you see inverted diminished, then magnification will be, by sign it will be negative, but by magnitude it will be same. Let's move on to a question. A concave mirror of focal length f produces a real image n times the size of the object. The distance of the object from the mirror is. Okay, so you have to find the distance, object distance, okay, not the image distance, and it came in Comet K 2023. I know many of you are preparing for Comet K, so I have included one question from Comet K. So focal length is given f and it is given concave mirror. Okay, so what is the suppose we know that for mirrors magnification is given by minus v by u. Okay, and for this particular question, because nothing is mentioned, everything is superficial, we will take that we will not consider the sign initially. Sorry, the information is given in the question, real image is given. Okay, so real image, so as you can see, real image is given. That means if this is the mirror, u is here, v will be somewhere here, so both u and v both will be negative. U and v both will be negative. Real image means everything on the left hand side, even focal length will also be negative. So let's put that value over here. Okay, it says that the size of the image is n times the size of the object. So magnification here is given n. The magnification here is given n. Very important. And if you put the sign minus v by minus u equals to n, or v equals to minus n into u. Okay, obviously v will come negative. You don't need to worry too much about it, right, because it is on the left hand side. Now you have to, what you have to do, you have to put the values in the length equation, mirror equation, sorry. So what is the mirror equation? 1 by v plus 1 by u equals to 1 by f. Now as I said, what is v? V is minus u, 1 by minus n u. What is u? U is minus u. Okay, and u is negative, and focal length is also negative. Everything is negative, so negative, 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 they will cancel. Negative, negative, negative will cancel. Now take 1 upon u as constant, and you will get this as 1 by n plus 1 equals to 1 by f. Now do the cross multiplication, you will get f into 1 by n plus 1 equals to u. right? So this will come here, this will go there. Now do the calculation. So u equals to n plus 1 by n into f. This is the answer. So correct answer is option C. Right, just simplify, n is common, so it will come over here. 1 plus n, I have just inverted it and I written it as n plus 1. I can do that, right? Now let's move on to the another MCQ. A person wants a real life image of its own. So I want a real life image of my own 3 times enlarged. So 3 times enlarged, where he should stand in front of a concave mirror of radius of curvature 30 centimeter. Now here also the image is a real image. Okay, real image, that means it has to be more than focal length. Focal length is given, radius of curvature is given 30 centimeter. So R is given 30 centimeter. So what is focal length? Focal length is 15 centimeter. Okay, so all the distances has to be greater than that 15 centimeter. Now what is the magnification? Magnification is equal to 3. Real image, that means minus 3, right? Real image means inverted. So minus 3 equals to minus v by u. Okay, or v equals to 3u. V equals to 3u. Now let's use the mirror equation. 1 by v plus 1 by u equals to 1 by f. Again you can use the sign convention over here, but in real image cases all of them will be negative and negative will cancel, so we are not using the sign over here. We will just put the values. You can put the values. V will be negative, u will be negative, even f will be negative, everything will be cancelled. So it will be 3u plus 1 upon u equals to 1 upon 15. Okay, so 1 by u equals to 1/3 plus 1 equals to 15, 1 by 15 that is, or 1 by u into 4 by 3 equals to 1 by 15, or u equals to 15 into cross multiply 4 by 3, so will be 5, so 20. So answer will be 20 centimeter. Correct answer is option B, right? So even if you think that mirror is easy, sometimes it can be tricky if you are not practicing questions enough. So practice makes you perfect. So don't stop practicing, and it is always advised that once the lecture is over, you should download the PDF, read the PDF once, so that your retention is better. It is in research we have seen that students who are doing a little bit of practice, they remember things better, they understand the things better, and in the long term they perform well in the exams as well, right? So if you are someone who often struggle to remember things or often forget things, then you have to, what you have to do, you have to download the PDF, read it once, and then practice the homework questions that also I am giving it to you at the end of the lecture, right? So here is the homework question. Small homework, small question practice also improves your learning. That is the reason I am giving you homework every day, but I do not see too many answers coming in my way. So a linear object of height 10 centimeter is kept in front of a concave mirror of radius of curvature 15 centimeter at a distance of 10 centimeter. The image formed is magnified and erect, magnified and inverted, diminished and erect, diminished and inverted. Pause the video, answer this right now in the comment below. This is an easy question, you don't need to think too much. Just pause, answer it in the comment below. Next question. An object is placed at 20 centimeter in front of a concave mirror, produces 3 times magnified real image. What is the focal length of the concave mirror? So again, pause the video, answer it in the comment below. Those who are smart, they don't need to solve this question. This is a hint. They can answer it from our lecture itself. So if you are observing the lecture clearly, then you can answer it without solving it, right? So with this note, I would like to end this lecture today. And obviously we are the #1 channel of KCET, and if you are not subscribed to us, then you are losing it out. You must subscribe to our channel and share this video with all of your friends so that they can also benefit, and whenever you are discussing amongst yourself, then that also beneficial for you only, right? With this note, I like to take leave of you, and I'll be back with part 2 very soon. Till then, bye.